16th Proof of Stake. In the last lesson, I introduced proof of work as a mechanism to prevent data from appearing and committing fraud in the blockchain. At a glance, it seems like a very fair system, since nodes that makes much effort for computation can earn reward. However, there are two major drawbacks that is often discussed in proof of work. One is that it requires huge amount of electric power to maintain it. The other is that malicious one node or a group of nodes with a powerful computational power dominate more than half of the total computing power, so that they can control much of the transactions in the blockchain. I first speak about electric power consumption. Block is generated only once every 10 minutes, for example in a blockchain or Bitcoin. In other words, only one node can receive reward in 10 minutes. For that reason, in order to make mining successful and profitable, you have to work on calculation by constantly running dedicated equipment. As a result, each node continues to work on to succeed in mining, so that the total electric power consumption is enormous. Then let's study about another problem, 51% attack. I will tell you in detail and the explanation of mining after this class. As a result of each node computing in the process of proof of work, they may find nulls almost at the same time. In this case, multiple blocks are generated, and the blockchain is branched. After that, the node which succeeded in discovering nulls connects new block to the block it regards correct among branched blockchains. And the blockchain extends more longer than the other is authenticated as correct blockchain. Well then, we will return to the 51% attack here. Think about the time when the blockchain branches. At that time, it is 51% attack to forcibly extend the blockchain containing the block, which stores illegal transactions such as double payment. Once a block is created, the transactions stored there are approved. In other words, approval of a transaction means that any node finds the nulls and stores it in a block. If certain transaction data is stored in one branch block, at that point it is still the first level of approval. After 5 blocks are connected and then approval at the 6th level is reached, it is reliable approval. And among the blockchains branched, 6 connected blocks are the correct blockchains. However, 6th level is only certainly reliable. It is likely that the blockchain is regarded as correct if there are actually 2 or 3 connected blocks. If a malicious node occupies more than half, that is, occupies more than 51% of the total computing power, the block, including the falsified transaction, which becomes its own profit in the branched state, surely reaches the 6th level approval earlier than the other to make it the correct blockchain. 51% attack means trying to gain a profit by stretching one of the branched blockchain by a certain node occupying more than 51% of computing power. Therefore, the consensus algorithm developed to solve these problems is proof of stake, which is planned to be introduced to the Ethereum. Proof of work gives the right to generate blocks according to the workload of the node, whereas in proof of stake, the right is given according to the coinage, determined by the number of coins times the number of days when the coins have been held. However, it is not simple, because high coinage doesn't mean that the owner is given the right. The owner of the right is randomly chosen and the probability is proportional to the coinage. A series of flow until getting the right is called mining in proof of work, on the other hand, called staking in proof of stake. One of the major problems of proof of work solved by proof of stake is the huge amount of electric power consumption that I mentioned earlier. Since it is the randomly chosen node that is given the right to generate blocks, the electric power required is reduced considerably because there is no process of fighting in computational complexity. Moreover, proof of stake solved the low 51% attack resistance in proof of work. In proof of stake, If you launch 51% attack, you need to hold a large amount of coins to store illegal transactions that will benefit yourself and the block and get approval. However, if you actually launch 51% attack, the reliability of the coin declines and the value of the coin you save for the attack will be worse. And therefore, no node will launch 51% attack on proof of stake. In this way, a proof of stake solves the disadvantage of proof of work, but proof of stake has the following disadvantages as well. First of all, the more the owner accumulates coins, the easier it is to succeed in staking. So the number of owners accumulating coin increases and liquidity is lost. As a result, the original value of the currency is lost. Secondly, the more coin you have, the easier it is to earn profits. So some rich people will gain more profit and there's a possibility to spur on concentration of wealth. The last is nothing at stake. In proof of work, when a blockchain branches, you cannot get reward unless you connect the block to the blockchain that is the longest connected and correct. So it has features that make it easier to convert to the longest blockchain. However, proof of stake can earn reward if you hold a lot of coins and leave them. So there is no motivation to connect blocks to the longest chain. In other words, even if the blockchain diverges, you will not suffer any damage, even if you have approved all transactions by connecting blocks to both blockchains without spending nothing. As a result, it is hard to converge to one blockchain, which means that legal transactions are approved. That's all over this time. Although I would like you to understand proof of work, of course, keep in mind that proof of stake is also a consensus algorithm expected to be introduced in the future.